Hey calculus students, we're here to look at section 1.2 one more time, defining limits and using limit notation. So in this problem we're going to be looking at left and right hand limits and also general limits to see when they exist. So in the top problem f of x, let's first look at the limit of our function f as x approaches 2 from the left-hand side. Another way of thinking from the left-hand side is you can think of as less than 2. Left meaning less than. So less than 2. So when you're looking at this piecewise function, it's real important. If we're doing from 2 from the left, we think of less than or equal to 2. So we're looking at the top part of my piecewise function. So as we approach 2 from the left-hand side, my limit would be 2 squared plus 1, or 5. So this limit would equal 5. Now, right-hand limit of our function f would be written as x approaches 2 from the right-hand side using a little plus sign. And so plus, or from the right-hand side, you can think of as greater than 2. And so we're looking at the part of the function that's greater than 2, and that would be the bottom portion. So the limit there would be 3 times 2, which is 6 minus 1, which is also 5. So in both cases, the left-hand limit and the right-hand limit are both equal to 5. Therefore, we can say that the general limit of our function f as x approaches the number 2 in general is equal to 5. Now let's look at g of x. G of x has a very similar function, piecewise functions, but this time we're going to be looking at less than -1 and greater than -1. So let's look at the limit of our function g as we approach -1 from the left-hand side. So again, remember, left-hand side means less than, so we're looking at the top portion of our piecewise function, and -1 squared is 1, and 1 plus 1 is 2. Now, if we look at the limit of our function g as x approaches -1 from the right-hand side, indicated by our little plus sign there, again, -1 from the right-hand side also means greater than 1. So look at greater than 1 would be the bottom portion, and then we put a -1 there and get -3 plus 1, which is -2. So since my left-hand limit does not equal my right-hand limit, then when we have the general limit statement, limit of g as x approaches in general -1, then this would not exist, because my left-hand limit is different than my right-hand limit.